Hello. Hi, hi, hi. Hello. Hello. Yeah. Hi, good evening, everyone. I hope you guys are all doing well. We'll be starting our session most probably. Um, we will wait for another 2, 3 minutes and probably we can start with a little bit of introduction, what we do and uh, what is the product that we are going to talk about today and what are the quite, important specifications that are associated with the instrument and how can we help the scientists or the executives who are working with the process related studies in mammalian upstream or let's say about your fermentation or bacterial, how we can help them to optimize their process and making their progress in a better way. So probably we can start and we'll see that how we can introduce some of the important sessions over here. So let me just give you a little bit of introduction that this is a journey that we'll have. This is a discussion that will focus on an instrument which you can see in the frame is mentioned as the NOVA BioProfile FLEX2. And the journey with NOVA has been 2 years, most probably that our company, MSP Lab Instruments Private Limited, has taken off. We are based in Hyderabad and we do it a lot of instruments, and our portfolio is very big. Let's say you are doing some upstream activities, we have instruments where that can help you to optimize your process and let's say to help you in the cell counting as well. We have instruments from Nova brand like BioProfile FLEX2 and the FastCDB, which we have already discussed earlier in the session. And when you come to the protein characterization part after the downstream processing, we have a different instruments from Biotechnique, especially from the Protein Simple brand. And when it comes to the testing or determining the different analytes involved in any sample or associated with any sample, let's say blood, plasma, and all. We have Luminex instruments, we have Jace, we have Ella, we have some other instruments like Morris, and which can help and you modify the activities which are basically high throughput instruments, and probably they can help you to understand the real concept and mechanism of your work. So we'll not go into the detailed process of explaining all the instruments. So we'll definitely focus on today's presentation. So we're going to talk about Nova biomedical instruments, and I can briefly say that the history that comes out with Nova, it's a biosensor technology company, and we which probably deals with the sensors, biosensors available in the market. And earlier, they used to innovate, sensors which were being used at biological facilities, and they had a very good track record of providing and innovating and constantly upgrading their process of, you know, uh, taking the biosensor technology to the next level. So let me just give you a brief introduction of the Flex 2 and what it actually does. It's so we can basically say that it's a bioanalyzer, and it has been designed for the analysis of your samples involved in some of the parameters from your bioreactors, some class, or the cell stacks. It all depends on the individual or the company or the process that you are following in your in your activities. So this instrument, it's obviously a high throughput instrument and have comes to come with four testing modules, and you can definitely say it's a cell culture analyzer, which is totally dedicated towards the cell culture analysis. And the third point suggests that it's a maintenance free, that you don't get a external liquid handle or liquid bottles where you can see that your samples or any other liquids that are being used in your systems are going out or coming in. So you don't get an external pipe or tubing or any source of maintenance activity that needs to be done manually. Uh, Rather than doing those activities in other high profile instruments, we have incorporated sensor based technology over here, which generally comes with a microsensor card, which is a kind of um, you can say about some credit card or debit card size. Comes in a size of debit card or credit card, which can help you to identify the analytes or the level of analytes that you have in your culture. And the fourth point is the most important point, which we call the robotic precision. It means the automated sample aspiration and dispensing. It talks about the homogeneous mixture that we built when we mix the samples before we load it any instrument. As I told that it comes with core parameters that includes 16 tests, which will talk in the latter slides. And obviously, there are different modules involved here. Some are chemistry, some are gases, some covers the cell density and viability, and some the osmolality. So this is what the instrument had. These are the main components of the instruments, like uh, there are different sampling ports of the instrument. The first one is your manual injection, where you can manually load your samples. There is a carousel tray over here, which can allow you to load around 24 wells. And this is a 96 well plate, deep well 96 well plate. And obviously, you can go ahead with a 96 sample test at a time over here. So the features include a touchscreen display, which will have uh, you know, which will have the capacity of performing the instrument activity as well as the data bridging activity with a separate computer. So this system doesn't require a separate computer, of course. And I told there is a 24 position carousel tray where you can just load and select your protocol, and you can leave the system as it is by selecting the protocol and putting the start button on. It will automatically analyze the data. And there is a syringeal manual board, there is a 96 volt board, and as I told that there is two different computers that has been established with the system. That makes the system more advanced in the market, as it comes with most onboard host and the bridge computer. That's means an onboard computer and the bridge computer. The onboard is the one which helps to get the data from the sample, and which normally take out the data from the hardware components. And the bridging computer is normally nothing but your normal computer, which has been there with a separate tab where you can open the tab and you can use it as your own computer. And there are reagents obviously involved with the system, which are cartridge based, and the cartridge based management system helps to identify or to make a track or record of the uses of your reagents. And the sensor cards obviously doesn't require any sort of manual maintenance. So, as I told that there are different modules that we need to talk about and focus on. And the first one is will be the phase and gas module, which contains your pH, PCO2, and O2. So the reason behind providing the limited parameters of 16 is to provide the main critical parameters or the attributes which nowadays scientists are mostly focusing on, rather than providing a bunch of parameters where there won't be any useful which are not be going to be more useful for many of the people. So on an average, the parameters that this instrument covers have played a major role in the optimization industry. So the gas module has the pH, PCO2 and PO2, and you know, right, how the gases and the pH, but optimization had a major role in optimizing the process. And the PO2 comes with a dissolved oxygen pad, and the PCO2 as well, and the pH. And there is a microsensor card for it, which covers the gas module. And there is another chemistry module, which will have your glucose, lactate, glutamine, glutamate, ammonia, sodium, potassium, and calcium. Okay. And the one more module, which is the external additional module, which is your osmolality, which comes with an 48 positions. And as you know that you can load 48 tubes at a time, and one by one you can go ahead and do your osmolality test. And there is one more optional module that comes with the cell counting and viability capacity. Like you do not need an external system to just do a cell count for your cell sample. So it means that once you load a sample into the system, it can give you the entire gas parameter, chemistry, osmolality, and the cell counting and viability, and the online model of sampling where you expect that your analyzer will be engaged or it will be integrated to a separate system of bioreactors where it can automatically generate the data according to the time frame. So this is the most important part where when you expect that a high throughput instrument that should be integrated into your lab or into a system, it requires yeah, understanding in the time frame how much time it takes generally to analyze the sample, and it matters a lot, and how much volume of sample it requires. So the NOVA specifically not only it focuses on the large volume cultures, but also it really focuses on the small volume cultures, because the small volume, the optimization mostly happen, the 70-80% of the optimization happens in your small volume cultures, which has a major role in order to finalize your process. So, to understand to mitigate that process, the instrument has come up with a very minimal volume of sample that can be around 135 microliter for chemistry, 135 again for osmolality, 135 for cell density, and 265 for gas model. And if you're at a time going to have all the parameters to be tested, then you can go ahead with the 265 microliter sample, which will take around 4.5 minutes. So the automation that has been done with the system and how it is efficient in the market, and that there are a lot of questions that has been asked, that how the automation part has been proved or showed efficiency in the market, and how far or how long the system performs it in a better way in order to require a manual intervention. So first of all, the system, so it is a very general concept of handling a sample, and identifying the components that are there in the sample, and to make a level of their or the range of products that are available, and how much quantity which are available in the sample. So just before going to handle the sample, we generally mix the sample to make it in a homogeneous mixture. And there are, see, the handling, there are people who mix the sample up to 10 times pipetting, and there are people which you just 5 times pipetting. So there is a hell lot of difference of doing the preparing the mixture. So in order to mitigate that, in order to make a homogeneous mixture for all the samples, there are automated, aspiration and dispensing, and there are dilutions also available in order to dilute your sample. Let's say your your parameter level is going up, it's going high. So in that case, there are automated dilutions involved. You do not have to go ahead and dilute some other buffers or media into your component. Of course, not media, because your media will contain a lot of components which might interfere in your analysis. You are going to add some buffer or some neutral components like water. So in that case, the system already have some solutions which are quite neutral and doesn't interfere with the parameters and perform an auto dilution. That system comes with three different auto dilution ratios that I'll talk about in the latter slides. But yeah, so the maintenance part that I told, that there is no manual intervention required for the system until and unless you just have to go and press the buttons in order to perform the tasks. So it's just there are procedures or processes but the company recommends that after every process you just do a clear wells in order to see that there has not been carryover samples from other you know uh, from the last experiment. So the system automatically performs that activity and performs a WASP as well. So in order to see, like in order to get a confirmation, you can definitely do a manual, process so that so you can get a clear data without any intervention or interference. The system is completely 21 CFR Part 11 compliance, which you already know that it is required in order to establish the entire process into the manufacturing section and the quality. That is the quality check of the system. So normally, when you perform a QC test, you load the reagent or you manually do the QC test, and so as to see the whether the values are coming in the range or not. But here, you get automated QC. You just load the vials into the place and keep it there. Whenever required, you can perform your automated QC or automation QC. You can obviously fix the timing in order to get the QC data. This is how uh, front side of the instrument, I won't say the back side. Yeah, of course, the back side of the door, but this is how the instrument looks like. You can find these are the cartridges that are required in order to perform your experiments. This is your QC section where you can put your automated QC files. These are nothing but your trypan blue and some other deproteination solutions, which helps in checking out the CDB module activity, your cell counting. Here comes your chemistry sensor card, and here comes your gas sensor card. You just have to open the bar and you just have to keep the card as it is, so it will perform the activity. So this is what it is. There is no, complexities in the instrument, and let me tell you that it is much easier to remove the cartridge and to put it into the system. And once you remove the cartridge, the system will automatically, see that the cartridge is not there, and you will see the system is sending out a notification of that. And once you install the cartridge, the system will take a pause of around half a minute or 1 minute to identify and detect the system, because there are RFID tags installed into the cartridges, which helps in detecting the cartridges as soon as it has been put into the system. We'll discuss that later. So the technological part, which is more interesting, obviously, to understand that why the system has a greater importance in the mammalian cell culture market, or let's say about your insect or bacterial, or any other cell culture process that you're doing to enhance your process. The system, as I told, that it has three different technology that has proved the system very well in the market. The first one is the microsensor technology, and the second one is the digital optics. Third one is your freezing point osmometry. Microsensor technology, when I speaks about microsensor technology, then obviously you understand that I'm talking about the parameters like the chemistry and the gases, because the two sensor cards have the capacity to do the parameters of your chemistry and gases. And there are principles which are involved in the measurement that the sodium, potassium, ionized calcium, ammonium are measured by the ion selective electrode, and those are minute electrodes which are installed inside the channels, which has been covered by the silicon cover, where you see a current and you see a current flowing through that, and that is how it measures. We selectively measures the activity of the ionic species. And the pH is being measured by the hydrogen ion selective membrane, and CO2, O2 is by the pH sensors, and the glucose, lactate, glutamate, glutamine, all the other, components are being measured by a reaction where they measure the H2O2 hydrogen peroxide production by the enzymatic reactions that happen in the sensor. So this is how the sensor cards look like, and it's easy to install the sensor cards into the system. You just have to open it from the packet, and you just have to keep it in the section, and you have to press the bar which I told. So this is how a sensor card backside looks like, and this is where the sample enters, and this is where the sample will come out after the analysis. These are the some silicon electrodes where the current will flow, and the system will identify or detect the level of the parameters available. And the backside you will get an RFID tag also, which when you install into the system will automatically detect that you have installed a card, which will show you the expiry as well as the number of tests that are available. So osmolality, as I told that there was a technology that I just told that bridging point osmometry. So generally in labs we have had the experience of handling osmometers from advanced instruments. I hope that most of you have gone through the instrument, have tested a lot of samples with the instruments, which uh, generally release a tuck 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 sound. Uh, Once you test a sample, obviously. So this system also had the same technology, and there is nothing more to discuss about it. So it does compare the sample's osmolality with the neutral water, and just it's just freeze out your sample and see that how much solute is there in your sample, and accordingly it calculates the osmolality. And just to give you a clear understanding that for water without any solute, if you freeze, the time it will take, and if you compare that with the media which contains water along with a lot of solutes, obviously that will take a lot of leisure time than the water. So that is how it measures the osmolality. Not going to explain in detail, but yeah, there are formulas which are involved in this. So the one more is their digital optics technology, which is nothing but your CDB methodology, which you call it as your cell density and viability methodology. The system uses very universally accepted trypan blue exclusion method that you know already, that the viable cells, they won't take the trypan blue dye into their body, of course, because they're intact, and the non-viable cells, which are obviously have been ruptured or somehow been stressed out, the trypan blue can be entered into the cell membrane, and you can identify as a dead cell to that. So these are some of the images to show you that how accurate is the cell counting of the system. You can see the first image shows a two cell line which has a obviously high cell count, and in order to get each and every cell of different sizes and the dead cells or the granule particles that comes in the cells as well, the system identifies all of them perfectly, and the AI that has been uh, you know incorporated into the system has proven its ability to identify each and every part of of the cells and the live cells and the dead cells as well as the granules in a perfect way. So this is a concept of showing you how the system counts the aggregates, of course. So all other aggregates, sometimes manually we check it as a one or two cells, and the system really identifies it and particularly count all the cells. Sometimes you see blebbing when you feel that your cells are stressed, and on that level also the system identifies the spread over cells and counts it as one cell. So this is how the system performs the cell counting. But the good thing is, this is this is a very important point to note about the cell counting capability of the Flex2 is it can go up to 160 million cells per ml, as much as you can think of it, because I do not think there will be such cultures available in the upstream culture right now, which can be expected as 160 million cells per ml. But yeah, the system has the capacity to go beyond to go beyond 100 million and can go up to 160 million, and the minimum will be the 50,000 cells. So this is the homepage or the dashboard of the instrument, and this is how it looks like. You can definitely see the time and the date over here, and this symbol signifies the scheduling activities that is set with the instrument or the set with the instrument or you have set manually. This is the chemistry sensor card, this is the gas sensor card, and this is the cell counting CDB cartridge pack. If you click over here, you will get to know that how much of your cartridge is left for your test, how many samples you can test with the sensor card or the cartridge. So this option will show you both the cartridge as well as the sensor card. The CDB will only show you about the cartridge because there is no concept of sensor card for the CDB. Here you see the parameters involved over here, and the CDB itself contains three parameters, which combines all these 13 parameters to 16. And these are the sampling options. Here you get the dilution option for the chemistry. Here you get the dilution option for your cell counting, and you choose your protocol. You modify your protocol accordingly. You can go ahead and do your multiple sample tests from your same protocol. Once you optimize it, you definitely get an option to enter the vessel temperature in order to get a significant data when you change your temperature for more productivity. And obviously, there's a simple sample volume. Whenever you click on the parameters, you will get that how much minimum volume of samples you require, and there's the pre-dilution multiplier in such case when you are expecting that you have already diluted your sample and now you are confused to measure the data how you can go ahead and put the dilution over here manually. The system will factorize the data once it analyze the samples. So as I told, the dilutions that are available for the chemistry is 1:1, 1:2, 1:4, and the CDB that I told is 1:1, 1:2, 1:6, which can go up to 160 million cells per ml. And the most important thing is to understand the reagent or the calibrator product, as you know, that for every single experiment or before you perform any experiment, you make sure that your system is calibrated and all other channels that you're using is being calibrated so as to give you a correct result without any error. So there is a pH and gas pack which comes with your reagent pack. There is a chemistry pack which contains two. One is a reagent and calibrator pack. The CDB pack consists of two. One is your CDB reagent pack, and one more is your Japan Gluc pack. So this is what the reagent packs do you require, and two more sensor cards like the gas sensor card and the chemistry sensor card. Obviously, when you think of installing a sensor card or the reason pack into the system, you will definitely become worried that how the shelf life or the use life of the reagents will be. So it is quite in healthy. It is quite healthy. Like I say, that the chemistry cards have a different version of shelf life and use life. There are low volume and high volume sensor cards. Accordingly, the use date, use life will vary, of course. Generally, for high volume, it takes around 14 days, and for low volume, it goes to 21 days of your use life. So that's a quite a bit long, quite a bit period for your you know analysis of a batch. So normally the two batches go ahead for 12 to 14 days, which I think is a complete card that will take for your batch, and you can definitely do a multiple sample test with the batches. So apart from the Flex2 that I told, there are the three different basic models of the Flex2 instrument, which quite might help smaller organizations which are not focusing on having or integrating a lot of parameters which are quite optional. So yeah, as I explained earlier, that the Flex 2 comes with different optional models like osmolality, CDB, and online sampling mode. So these three are the optional modes. You cannot, you can definitely disintegrate that from the system, and here you get a normal Flex 2. And the basic models costs half of the amount that you get for the Flex 2 instrument. But the good thing about Flex 2 is that you can definitely upgrade it as much as you require some other parameters. But if you consider the basic instrument, you cannot definitely upgrade it for further additional options. So the basic A, as you can see over here in the display, that comes with only the gases and chemistry with some extended ranges, and the basic B comes with the pH and gases, but with standard ranges. The basic C comes with only limited ranges, and there are different only sensor cards that you can use and the resin cartridges. So as I told that if you buy a complete Flex 2 system and you are trying to connect the system with a bioreactor for automated operations, let me tell you that the system can accommodate 10 bioreactors at a time and can give you the data also um, one by one. So this is what an auto sampler looks like, which will be connected to your bioreactor, obviously. And if you are using 10 bioreactors, so 10 auto samplers you have to engage each of the to the 10 bioreactors. So this is the ESM module, which is kind of a mediator between your online autosampler and the system, which helps in sparging the samples from the bioreactor and then send it to the instrument. And this is how a complete Flex 2 instrument looks like. Here you get an additional osmometer, so you get a CDB installed in it. You get the online autosampler, so you get a complete system out of it. So this is all about the main points or the important discussions about Flex 2. And but now look at the data that we have generated comparing the instrument which is quite popular in the current market, called from Roche, obviously. Uh, they have become a major competitor to us, but yeah, somehow we have proved to be a better version of their process. Obviously, that we obviously discussed over here, and you can definitely generalize that after the presentation. And while comparing the data, we saw that the system has a high quality productivity, high quality data that it's generating, and exactly matching with the data that CTEX is producing. You can say over here the glucose correlation and the glutamine and the ammonium correlation. The R square value says that it is close to 0.99, which is your one close to one, which is quite accurate. And the osmolality shows the exactly what the value right showed in the advanced instrument, which is quite surprising. And I was telling you in the basic section that the instrument comes with some ranges. So here are the ranges, basic A and basic B, basic C. You will obviously see there is a significant decrease in the ranges when it comes to basic C. So yeah, basic C will be much useful for people, those who are working with bacterial or yeast cultures, because for them, they would not require many of the parameters which are involved for mammalian cultures. But yeah, the ranges that has been provided and the parameters that have been provided with the basic C would be more useful for people, those who are handling bacteria and yeast. These are some of the principles of the measurement. I'm not going to explain the things in detail because there are some concepts, equations involved which has to be explained properly, where you need some theories and the principles in order to understand the concept. But yeah, some other time we'll go ahead, we'll discuss about the principles that are involved. That is quite understandable. When you think of a sensor card, you must think that there are channels which has been built up, and um, there has been immobilization of some the membranes or the nanomembranes, which will be helpful to identify the gas parameters and the pH as well. And for your glucose, lactate, glutamate, you see some enzymes that has been immobilized inside the channels, which will help you to perform the reaction and give you a perfect data. Okay. And that is what I'm going to explain over here. That you see that when the glutamine reacts with a water in presence of the enzyme, it produces the glutamate. So there would be enzymatic reaction inside that, though it's not been clear and has been a proprietary knowledge for from the principal company. But as far as I studied from the background of biosensor technologies and making a compact device or the to measure the sensors. It could be the region behind it, and there are some chemistry concepts that have been involved. So this is what I was talking about, the osmolality measurement, and this is how the freezing point depression works, where your freezing point depression is equal to like freezing point depression, which is the difference between the freezing points of the pure solvent and solution, is equals to the freezing point depression constant of the solvent. And M is the molality of the solution. And cell density viability, obviously, the how the system identifies because it uses the Japan blue exclusion methodology. So I think that's all from the NOVA biomedical FLEX2 instrument. As a distributor, we have we have received a lot of information from the team, and uh, it is helping quite a lot to the scientists to get the knowledge as well as the experience out of the instrument by using it in their process. And it is constantly evolving as a game changer in terms of saving time and producing a quality data. I hope that this presentation will clarify some of your basic doubts about the system, as there are not much information available in the internet. But I know there would be a lot of questions which might come to your mind. But I would say that it is a completely simple instrument and doesn't require much technical, aspect or technical interventions in order to understand that. It's quite a simple to put your sample, get the data, and probably the analysis or the optimization that a scientist will do will require more and more knowledge in order to optimize the process. So, but anything that will be a question to your mind regarding the presentation that we had right now. Would be happy to help or would be happy to answer you. I know that there are no questions till now that we have got, so probably we can wind up the session and whatever questions or any doubts that you're having or any problems or any any chances to serve you, any chances that you're looking for to get the instrument back into your lab. We will try to help you to train and to definitely perform a demonstration to show you that how it can be a game changer to your process. So I think this is the end of the presentation. So thank you so much. Thank you all of you for your patience for the past half an hour. I hope that we had a very good presentation, obviously, because I have really uh, you know uh, put all the informations that was there with the system and which might give you a quite a bit good understanding about the system at least. And slowly, when the process will um, when we see that the instrument is working in the process and is involved in the process, we'll see more and more challenges, and that could be a learning part for us, all of us. I'm not telling that this could be a learning for you guys, but no, it could be a learning for all of us, because once you run the instrument, you might see a lot of problems or issues which can be your learnings. But yeah, definitely we have a very strong team, we have a very good application and service team who can definitely help you with that and can help you with each and every kind of your problems and issues that are coming in. So I thank you, all of you. Thank you for joining. We'll be winding up the meeting. We'll be having some more sessions on the instrument, on the principles. So stay tuned. We'll have another sessions in the coming weeks. So thank you, all of you. Good night.